thank you for having us here tonight. So we are two students, NMCT, that stands for New Media and Communication Technology. This is Stijn, he's my colleague. He's a junior developer. I'm actually a network engineer. I'm Sebastiaan. If you want to contact us afterwards, here are our details. So we will be talking about two projects. First up is Chocol. It's an app combined with some hardware that lets you drum wherever you want. And then there's the control room of the future. That's a project we did with a company, Vinke, that implements the HoloLens.
All right, we'll start off with the Chocol. The idea is fairly simple. You'll download our app, you connect with the drumsticks, and you're already ready to play drums. How did we do this? Well, we implemented several technologies. First of all, we needed to track our drumsticks. The communication was via Bluetooth with the smartphone. We had to develop an application to play back the sound, and to all the hardware we designed a custom PCB which we made a case for using CAD drawing and 3D printing. Starting off with the custom PCB we developed, it looked something like this. We made this PCB using help from some external persons. The important items on this PCB are, in fact, the item on the right, this little black chip is actually the sensor we use in a gyroscope and an accelerometer. And in the middle you see the Bluetooth chip, which we use to communicate with the smartphone. Next up, you see the 3D printing we did to make the case for this PCB. We used here a wood filament to create like a feel of a real drumstick. Wood filament is actually a little bit of wood combined with plastic, which made it possible to 3D print. But as you see, this is fairly big, but it is possible to make it very small with microelectronics, and we envision it to be just as fine as a normal drumstick. We also see the drumstick being shipped in a case, which will charge the batteries inside of that stick. Any future expansion, of course, the application we can expand, but also implement machine learning to be more accurate about our tracking. Also the music library or the sounds we produce with our application or recording studio are also possible. But something we are looking into is applying our application with augmented reality. So even you don't have a physical drum kit, you can see your visualized drum set in front of you while playing with our set.
And talking about augmented reality, that's our next project. So we did the control room of the future. We called it HoloLens for Vinke. So who is Vinke? Vinke is a Flemish company from the west of Flanders. And they are a small company, but they are a global player on the market of small-scale biomass plants. So they build biomass plants on the campus of factories, and they burn their recycle their produce, and the heat is used either to generate electricity that's directly used on campus, or the steam is used in the production of like cooking food.
The idea is fairly simple. We envision the control room of the future not being in an actual room. We see it. We will use augmented reality to display all the information right in front of the user to guide him with several tasks. For that, we had to implement several technologies. First of all, tag recognition to let the HoloLens know which sensor is in front of him. Also, we designed a binary protocol because we had lots and lots of sensor data. So to eliminate overhead, we had to use a binary protocol. The application was made using Unity, also a universal Windows platform application for the HoloLens. All the data was stored on Azure on Cosmos DB.
So the tag recognition we were talking about, you can see it here. We used a product called VUMarks. They are made by a company called Viforia. And what these are actually some kind of very specialized QR codes. We made a very simple design, but you can brand it however you want. And these allow you to very accurately track 3D objects in space. So we tried with normal QR codes, but VUMarks are even more optimized for 3D tracking. No more jittering like you have with normal QR codes. VUMarks were actually very difficult to implement because they are developed at such a rapid pace that the guidelines were always outdated. And it took us the better half of 2 weeks to get actually the first demo working, the Utah Teapot, very famous 3D model. And of course, then there was the binary protocol. You have to imagine such a power plant. It was a single power plant, had about 5,000 sensors, and they were sending data at a very rapid pace. To limit overhead, we didn't opt for HTTP protocol, but we developed our own binary protocol. The data was sent to the cloud about every 15 seconds, but we were not limited by our technology, but by the PLC data logger that was sending the data to the cloud that couldn't handle this much data at a time. We were working with about 100 sensors at the time, but expansion was provided. In the cloud, we worked with a data acquirer. This collected the data, then converted the binary data to readable data and stored it in Cosmos DB. Cosmos DB was made by Microsoft and published last year and is actually specialized in very fast data. So this was perfect for sensor data and working with this. But on the long term, we would store the data in like Elasticsearch, which would be optimized for machine learning and big data analysis. And in the end, there was the data distributor, which sent the data to the HoloLens so it could be visualized for the user. We have a little clip of how the project worked. Don't mind the quality. This is all because of the HoloLens itself.
Oh.
One.
All right, so that was a little promotion video we made for Vinke. So if there are any questions, we would love to hear them from you. Yes?
So you said because of the hardware that you used, you had a 50-second delay on any input that you had.
Yeah, exactly.
Did that become an issue when you actually looked at it?
I'll take the question.
Oh.
Yeah, Vinke didn't actually have any data logging over the internet before, so they were really looking into new technology, and what they acquired was second-hand data logger that was not really up to par with what the sensors were pushing. So we worked with what we were given, but if you use current gen technology for data logging, you could handle it much more smoothly.
Mm-hmm. Any more questions? Yes?
Since your project is for HoloLens, did you submit your project to the imaging camp?
To what exactly?
Microsoft has competition event for students around the world. They are using Microsoft technology because you use your project Microsoft Azure and HoloLens. So I'm just wondering if you also participate in that competition.
No, we actually didn't.
We didn't even know that kind of challenge existed. So
Yeah,
no,
so
we didn't. We did not submit it. Any more questions?
All right. Any more questions?
Yeah, great talk, guys. I just have one question for you. You were talking about Cosmos DB.
Yes.
I've never heard of it. Can you tell me what are your experiences with Cosmos DB?
It's very expensive.
Maybe we can chat afterwards.
Yeah, definitely.
Yes.
Sounds
Well,
good.
quickly, Cosmos DB is actually used for very quick data throughput and very large amounts. For example, a game, Halo, fairly well known, uses it to analyze the movement of players in game. So it was new at the time we were developing this project. So we wanted to try it because we had lots of data in a very fast pace.
Yeah.
Cool. Thank you.
Thank
All
you.
right, thanks for the question.
All right.
No more? All right. Thank you
Thank you
very
very
much.
much.